Is my audio working now? Is my audio working now? Cool. Welcome back to the advent of syntran. Today is day 21. Got a good feeling about today. Part 1 looks doable. So let's make a new directory and download the input. Also, the input isn't huge. I read the prompt last night and I was like, okay, this sounds easy. Well, I mean, relatively easy compared to like the last 2 days. But then I thought, well, will it be easy? Maybe the input is like a gigabyte of data, and that could be difficult if it was that big. Fortunately, we've got like around 100. Yeah, so we have 131 characters wide, and yeah, it's square, 131 by 131. So the input is not huge. Let me get into there. And let's take a look at the prompt and get the test input. Where is Google Chrome? Did I close? No, here we go. Day 21. So this is the test input. And my desktop audio is super loud. So we have a grid, we have a starting point marked by an S, and then we have empty spaces that are dots and hashes. The hashes are like walls or something where you can't move. And there's an elf or something who starts at S, and then at every, I'm going to call it a time increment, maybe that's a loaded term, but at every time increment he can go one step in every direction. And this is some sort of like parallel universe elf. So he goes left and he goes up. So he goes to any place that he can go 1 unit away, but not diagonals. He never goes to diagonals. He can't go here or here because they're, what, stones, walls, rocks, or something? Rocks, yeah, whatever. It doesn't matter. It's an abstract computer science puzzle. This has nothing to do with elves or gardens or rocks. So he can move anywhere that was an open space. So initially he can move there. And then on the second step, he can move anywhere that was adjacent to one of these places. So basically he can multiply himself by 4 on every step, as long as there aren't rocks. If there were no rocks, there would be 4 places, and then 16 places, and then 64 places at each time increment. But there are rocks, so it's not quite that explosively exponential. So at the second step, he can go here and there. Notice he can go back to the starting position. So from here, he can go any place that's 1 unit away from here, so he can go back to the starting position. From here, he can also go back to the starting position. So there aren't really 16 places on the second step. I guess there would only be 9 places, or I think my count is off, but it's not totally exponential because like some of the positions are not unique. But with rocks, there are only 4 positions on the second step. And then he keeps going for a total of 6 time increments in this example, or 6 steps, they call it. This is happening over time, according to the puzzle, so I'm going to call these time increments. And in this input, with all these rocks that are blocking his path, he can get to 16 different places. Now, is that cumulative or not? I actually don't know. I assume this is just the final state of things. At the final step, he can be at 16 different places, but that doesn't count like steps 1 through 15. Or maybe it does. I'm not really sure if I understand that part. Yeah, so this could explode almost exponentially, but the space isn't that huge. So like there's going to be a cap on the exponential explosion. Like, what's 131 by 131? It's probably 10,000, 20,000 or something. 131 squared, it's 17,000. So that's really not that big, even for the real input. I don't know what's coming in part 2. Maybe they'll make us do like 1 trillion steps or something ungodly large. But part 1 seems doable. I can think of an easy and simple way to do this, or I can think of a more complex but maybe elegant way to do this. I think I'm going to do it the more complex way, just to, I don't know, just to challenge myself. So you could just have a Boolean grid and keep track of, could he reach a place or could he not reach a place on every step. And then that automatically takes care of the equivalencing problem, where it can go back to the starting point from 2 or 4 different locations. That would take care of that pretty easily. Or you could just keep a list of all of the positions that he could be in, and then sort the list, and then get the unique entries in the list. So I think I might do it that way. This might scale slightly better. It's only a 131 by 131 grid, so even if you had to scan the whole grid for the basic approach, it really wouldn't take that long. But I don't know what's coming in part 2. I'm going to try this the hard and arguably elegant way. Maybe it's not the elegant way, maybe it's just an overcomplicated approach, but I think that's the way that I'm going to do it. Also, think about like a checkerboard. There's like this red-black pattern. Got red squares, or okay, let's call them white and black squares. Basically, he starts on, come on Google, load this image. Just show me the image full screen. Here we go. So let's say he starts on a white square. On the second step, he can only be in black squares. And then on the third step, he can only be in white squares. So at every time step, he alternates between white squares and black squares. I don't know if this helps you at all, but it does mean that you can never be at the same point in 2 successive time steps, because it's always going to alternate from white to black or from black to white. I don't know if that really helps much. It's just something to think about. So let's see if we can echo the input. I don't really need a log file. Okay, so that's the input. I'm going to load this into a matrix of characters. Yeah, and then we'll know the rock positions and the S position. The S position is also a dot, so if he starts here, that must have been an open spot. Okay, count the lines of the file. And then we're going to count the characters in the first line, and that's going to be the dimensions of the grid in the X and Y dimensions. Excuse me. Okay, so we have an 11 by 11 grid for the test input. That is right. And now I could use a for loop instead of a while loop. And then we can iterate character by character within that line. I guess it always happens to be a square grid, so you could make that assumption, but I like to be general and have different X and Y dimensions, just in case that's a possibility. I'm going to need to allocate a grid, but you've seen me write this exact code on about 10 different days. We've had plenty of grid problems. There's nothing exciting in watching me read a grid of characters into memory. And now we're going to get this with comma separators. but I have to allocate it ahead of time. It's just going to be empty strings initially. Hey, Kelly. Please don't jump. Please don't jump. She's looking at me like she wants to jump on the desk. It's gonna happen eventually. Okay, so there's our grid. I also want to, I guess, save the start location. Kelly, this is your first warning. You can't be on the desk. Go on, Kelly. Well, let's get you down from there. Callie is moist. I don't know what part of her back has water on it, or how that got there. So I want to know the starting location. XS for X start. Yeah, why not? So that should be somewhere around the middle of the grid for this problem. Five, five, that's it. Well, it's 6, 6 in a 1-based text editor indexing, so that's 5, 5 with 0-based indices. That makes sense. Now we're going to explode into parallel dimensions by splitting the elf into separate timelines. However you want to think about this. Time-traveling elf? I don't know. A quantum magician elf? It's an abstract data science problem. It has nothing to do with elves and rocks and gardens. So how many steps are we doing? Time steps or time increments. That's standard terminology in my field. Yeah, this is just hard-coded. It's not given to us in the data, it's just hard-coded in the puzzle input. So 6 for the example, but then they actually want to know 64. So that should be 64, but I want to see if I can get the test right first. And then we're going to loop through time. But before that, I think I want no. I was going to say I think I want like a grid for the previous time step and then a grid for the current time step. Like I'm going to modify this data and put O's in here. But I'm not going to modify this. This is going to be basically immutable after I read it, even though syntran has no concept of immutability. But I'm not going to change this. What I am going to do is have a list of possible positions. So at first, that list is going to have one number in it, and it's just S. What do I want to name this? P for positions. I don't know. PS for positions plural. Maybe just P. And this is going to be 2 by some large number. why not make it a power of 2? But before I do that, we've had other days where we work with directions and spatial dimensions, so I don't like having a magic number 2 for a 2-dimensional problem. So I think we did this in day 17. Yeah, so we had ndim is 2 for the number of spatial dimensions. I want to copy that, and then I want to have 4 directions and the vectors representing each dimension and north, south, east, west parameters. So I want to copy all of that stuff. Maybe I should put this inside my utils.syntran. I don't know, but I don't need it for every day. And some days they have like a different up, down, left, right convention instead of a north, south, east, west, or sometimes like the order of these is important, like on the day where we were tilting a platform, it had to tilt in certain directions, so like the order of these mattered. So I don't think I want to have this in the scope of utils.syntran. I think I just want to copy and paste it every day that I need it. So instead of 2, I want this to be and not that ndim. So we allocate like an empty list, and then I think I want a push function. And then I want p to be a global variable so that I don't have to copy it by value every time I call a push function. This is going to be np cap. And then I want a function to push onto the stack. You can think of it as a stack or just a vector. Do I want multiple stacks? Or do I want this to be a queue? I think I'm going to have a local variable of p from the previous time step. But globally, I just want 1p, and my push function is going to push onto the global p. Because I want to know the positions from the previous time step and then the positions for the current time step. And I don't want to get those mixed up because you don't want to like start adding positions based on current positions that you just added. You want to separate your time steps. So I want a push function. And this is just going to push a position onto the list of positions. That's the y position, or sorry, that's the x position, and then this is the y position, and then we increment np. So we grow the stack. And if the stack ever overflows that limit, do I have a check for this? It's going to be like this. But it's not Q. I think I have time today. Let's do a little error handling. Let's actually abort or exit if this error happens, because up until now, I've had this on several days whenever I have a queue or a stack with like a hard-coded upper capacity limit. All this does is print the error message, but then the code keeps running, and it will probably crash, but I can't guarantee that it will crash every time. So like the really dangerous thing is that it might keep running and just give you a wrong answer with no hint that the answer might be wrong, unless you like scroll up and check for this error message. So what I really want is a system exit. But this function doesn't exist yet. It should be relatively easy to add. It's just for testing. And I need to call this. Well, exit is not going to be defined yet. Okay, so we have the starting position, and then I need to push that. So this should print an error, and then maybe crash, maybe not. Okay, so it does crash. You get this stack trace, which reference a bunch of meaningless line numbers from the Fortran interpreter. But it prints this, but then it keeps running, and I really don't want to see this stack trace because it doesn't help me at all. Maybe, I know that this means the array is of type I32, so you at least know the type, but you don't know the name of the variable or the syntran line number where it happened. So I would rather hide this Fortran stack trace. So let's put that in the interpreter. Have I done anything here? So this function will take an integer argument. Do I have a void type? Okay, so print line, for example, is a void function. It doesn't return anything. At least it doesn't for now. Maybe it should. I haven't really thought this through all the way. And then the argument is an I32 type. This name is just exit, not exit underscore fn. Do I have I32 typed correctly? Okay, yeah, I think so. So this is a function which returns void, and it has one argument or one parameter, and that parameter is of type I32, and the name is exit status. But the name of the function is exit. So I have to push this, or I have to put this into my list functions. I don't think the order matters here, but I'm going to keep it consistent just in case because I can't really remember. And then I have to implement that. So this is the evaluator. And when I call exit, come on, man. So we're going to evaluate the parameter or the argument, which is just the exit status. And then we're going to call exit. Is it exit or is it call exit? I think its call exit. That's just I32. That doesn't work. I32, it's arg scalar I32. I just did this refactoring. I used to have a value type and an array type. And that was really dangerous because a value could be an array, but an array could also contain values. So I had this circular type dependency where arrays depended on values and values also depended on arrays. And that wasn't really good. I can only do that by using a pointer in Fortran, and pointers are very dangerous in Fortran. You'll get terrible memory leaks. That was actually the cause of my memory leak bug, because I was using a pointer where I shouldn't be, and then I had like a dangling pointer somewhere. But now, values can be either a scalar or an array, and then arrays can only contain scalars. So there's no more circular dependency. There's just a regular finite depth tree of dependency with no cycles. So yeah, this used to be just the argument I32, but now it's the arguments scalars I32. So there's a little more typing there, but at least I don't have circular type dependencies. I think that worked this time. I mean, it's compiling at least. I don't know if my exit function is right. I think I want to print something too. So this should not have this stack trace now. Or not. Because I'm not calling exit. Because this didn't exist until just now. Cool. So it prints that, and then there's no ugly, meaningless stack trace. It just stops. I think I actually want to print something from the interpreter though to say that like, hey, you called exit. We're aborting. We're ending. Do I want this to be red? Because maybe you want to exit with status 0. I'm going to make it red for now, but then I might actually check whether the status is 0 or not, and then change the color and the language of the message. And then what did I name this? Is it string or is it toString? I don't know what I typed, but Vim is totally locked up. Okay, there we go. Man Lua. I tried to like open a Lua manual somehow. I don't know what key combination I hit. Unfortunately, the interpreter is like 8,000 lines long or something, so it takes a second to compile. I mean, like, just core.f90 is about 8,000 lines. The other ones are all significantly shorter. Now this should print something in red text that says exiting with status -1. Cool, I like that. I might change that later, but I think that's good enough for now. And I have to remember to commit that at some point. I'm just going to commit it right now. I really should update the version number too, so that in my syntran repo I can tell you which version you need. Because if you try to run my code and call exit, but exit doesn't exist, it's not even going to parse. Okay. Now we have some kind of error handling. It's not throw catch, it's not an early return, but at least it doesn't just keep running. And now we should not hit this error. And I forget what happens next. I thought we might have an infinite loop. I guess not. So first we're going to want to get the positions from the previous time step. And I think I'm just going to copy the whole array, even if it's like 1 million elements long or whatever the NP capacity is. Right, I have NP, right? Yeah, NP is the number of points. So now we should be able to update these. Yeah, no, I'm going to reset NP to 0 because none of the old points are going to exist in the next step. Like with this white-black ordering, all of the old points are going to disappear. And then for every P naught up to NP naught, we're going to add we're going to push its neighbors onto the list of positions. It's really IP naught, because it's from the last time step. The 0 suffix means it's from the previous time step. This is somewhat standard notation. And then we're going to add every neighbor. So within this loop, we're going to loop through the directions. And then we're going to get the x and y position and add it to the point coordinate. So x is going to be p naught, IP naught, but this has an x and y component, remember? So we want 0 for the x component, and then plus dirs 0 for the x component, and then whichever direction that loop is iterating over. So that's x, and then we're going to have y. And those are 1s instead of 0s, because y is at 1, x is at 0. And then we're, first we have to check if there's a rock here. So if grid x, y not equal rock, then we're going to push x, y onto the list. So I think I just want to print that, but I don't want to print all million elements of P. I just want to print 1 or 0 through NP minus 1. And I need to do that manually because I don't really have vector slicing yet. Maybe just I. So I also only want to do one step, and we should get 2 points for the example. Right, because the example on the first step, we should get these 2 points. And so we got 5, 4 and 4, 5. Those are both right next to our starting position of 5, 5. So that makes sense. And in general, you could get duplicates in that list. So if I do 2 steps, you're going to see 1 point that's duplicated. It's going to be 5, 5, 2 different times. And so we got 5, 3, that's good, and 3, 5, and 4, 6, those are all good. But 5, 5 is in 2 places on this list. So we need to equivalence these points, and I think the best way to do that, unless you want to do the basic pigeonhole approach that I talked about in the beginning, where you just have a Boolean grid, that might be the better approach, honestly, but I'm going to try to do this a fancy way, which it might come back and bite me, who knows. I'm going to sort these points lexicographically by the x and y positions, and then I'm going to get rid of the duplicates. But instead of doing a lexicographical search, I think I'm going to convert the 2D coordinates to a 1D coordinate. So like in the first row, we're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the second row, instead of being like 1, 0, this is going to be 11. 11 through 20, and then 21 through 30. So there's going to be a 1D indexing, and then I can just sort a vector of integers instead of sorting a vector lexicographically. This is probably overcomplicated, but like I already have a quick sort function, so why not just reuse that? So this will pre-allocate my 1D indices. This is P1. And then P1 IP is going to be, how does this work? We have to multiply one of these by something. It's going to be the x index plus nx times the y index. And this is wrong, this is IP, not I. Okay, so we have something in the range of 0 to 100. I think that makes sense. So like 3, 5. Why does this grid have to be 11 by 11? It's not 10 by 10. Maybe I'll just delete a row so this is easier to think about. Okay, so now 5, 3 becomes 53, and 5, 5 becomes 55. And this is easy to think about because my grid is 10 by 10. But with 11 by 11, 5 comma 3 becomes 5 plus 3 times 11, or something like that. Yeah, so 3 times 11 is 33, and then plus 5 is 38. So now I have 1D indices, and these are easier to sort. So one of the things I did for day 17 is that I had a really shitty priority queue. And I tried to like implement a priority queue myself, but I did like a really bad job of it because I just wanted to do it a quick and dirty way. So I would just push things onto an unsorted queue, and then every so many steps I would sort the whole queue. That's really not a good way to do things, but now at least I have a quick sort routine. So do I want to copy this one? I think I have a better one. Where did I put this? Is there a 20? No, it's 19. So this takes an array, and then it sorts it, and then it returns a sorted array. Everything is passed by value, so both of these arrays get copied in and copied out. And I hope that should just work. So I should be able to do P1 equals, what is it, Q sort? It's just named, yeah, just named Q sort. Q sort P1, and then that should be in order now. That didn't work. I think I have this problem where I can't have an array on the right-hand side and the left-hand side. So I need a temporary array. Or I can just name the left-hand side something else. PS for the sorted points, and that is undeclared. Okay, so we had 49 and 59, those are already sorted, but then the second step is more interesting. So now these are sorted, 38, 58, 60, 60, 70. And now we can easily eliminate the duplicates because the duplicates are right next to each other. With the unsorted array, you have 60 here and 60 here. With a sorted array, they're right next to each other, so it's easier to eliminate. So now I need unique, like the Unix command unique. I want to implement this basically in syntran now, which just gets rid of duplicate things out of an array. This takes a vector and it returns a vector of I32 integers. I think eventually I just want to call sort inside of here. So yeah, then instead of calling Q sort here, I just want to call unique instead. So now this will automatically do the sorting and then only return the unique elements of V in. Okay, so initially I'm just going to over allocate. So worst case scenario, the unique vector will be just as big as the input vector. At the end, we might trim some things off at the end of it. So we're always going to have the first thing. And then we're going to iterate through the rest. And then if the current element is unique, we're going to add it into the output vector. So if vi does not equal vi minus 1, we're going to push that onto u. So u equals vi, and then iu gets incremented. I think that's it, and then we're going to have to trim things from the end. But I want to see if this much is right first. That doesn't work. Should start the loop at 1. Yeah, so we got rid of one of the 60s, right? We had two 60s. First of all, for the trivial case where it's already sorted and already unique, it just gets copied. That's good. For the case where we have duplicate 60s, the extra 60 got removed, but we still have 160. And then we have an extra 70 at the end because we haven't trimmed this array. Maybe I want that to be nu for the number of unique elements. And then we have to copy. Okay, so there is our unique array, and then I have to take these one-dimensional indices. Remember, we took 2D coordinates and converted them to 1D coordinates. Now I have to convert these back to 2D coordinates for the next iteration of the loop. So 2D to 1D wasn't too bad. We took the x index and added it to the y index times the number of x indices. Now to convert the other way, this is honestly tricky to get right for non-square grids, because you have to make sure you divide by the right thing and do the modulo by the right thing. So x is going to be the 1D coordinate modulo nx, and then y is just divided by nx, not ny. I think that's right in general. Fortunately, we have a square grid, so nx is ny, and even if I have this wrong, it's going to work for a square grid anyway. And okay, already reset np to 0, but I think I can do that lower down. Oh. Okay, so I pushed in here. So I think I want to reset it to 0 again and then push again. And then I want to print this again, just to make sure I did all of that right. So these are really duplicated, and then these should be unique. So initially I printed this, I had duplicates, I had 5, 5 in 2 different places. Now it should be unique, but it should be the same values. Yeah, I think that worked. Okay, now we have to do this for 6 steps for the test, and then 64 for the real input. So let's try the whole shebang. I think we're supposed to get 16. I really only care about the number of points here, but that looks like about 16. 16, cool. Let's try the real input. And we have to toggle the input, and I have to set the number of steps. So maybe I want to do that up here and have a global variable. So we had 6 for the test, and then we want 64 for the actual puzzle. And now, whenever I toggle between the test input and the actual input, this will also toggle the correct number of time steps. So this should still be 16. And then if I toggle this, it's going to print a whole bunch of stuff. This is going to explode almost exponentially. Copying is probably not the best way to do this. I probably should have pigeonholed it, but this was fun. Wonder what step I'm on. It was pretty fast at first. Obviously, it slows down as it goes along. Sorting should be the bottleneck, because sorting is n log n, where n is the number of total points, not necessarily unique points. Then basically everything else is order n. So I think this approach was overcomplicated, and it's also the wrong approach, at least for part 1. And I should probably not have done it like this. This is the part of the stream where we just wait for the code to finish running. I have no idea which step I'm on. While this is running, I need to get another drink, so I will be right back. Okay, where are we? Let's find out how this thing is doing. It's still running. Today's puzzle reminds me a little bit of Conway's Game of Life. We have some pattern that's moving around in a grid. Hey, Bad Cup. Did you already do day 21? Don't know if... Okay. Yeah. I don't know. You might want to leave immediately for spoilers then. This should really not take so long to run, but I shot myself in the foot by intentionally doing something that was overcomplicated. And I think I picked the wrong option. Got a crab gif. Rink's Craft Jam. I guess I could always go back and implement this the other way. My problem is I have no idea what my progress is right now. I have no idea how many steps I've gone through. And I am not saving my output. This is not teed to a log file or anything, it's just in the console. And I don't even know what the starting position was. Gonna look at the input. Spoiler warning. Okay, so S is at 66, 66. And what were some of my Y values? I think I saw a Y value around like 110 or 120. So we have a Y value of 118. So 118 minus 66 should be the step number. 118 minus 66. Sorry for all the scrolling. 118 minus 66. So I should be at step 52-ish now, maybe 53 by now. I think it went through another step. So it's actually not that much further to step 64. So I think I'm just going to let this keep running. Because if we start at y equals 66, we can only advance by one y value per step. So this has to be the step that I'm on. It feels really dangerous to me to use Syntran as a desktop calculator like this, because like, what if I have a bug and this number is just totally wrong? I would have no idea. Like I should really probably use Python or something. Like, look how long Python just took to start up. It took like a second or two to start up. And then, okay, it's the same number. It's a good sanity check. Okay, and it started up faster the second time I started it, so it's not always slow to start up. But Syntran, it always just starts instantaneously. I can't use arrow keys in Python though, or at least I haven't set up a shell alias to do that. With Syntran, I'm using rlwrap to run it, and rlwrap remembers my command history across separate invocations of Syntran. So I can go way back in time. You can even do reverse incremental search. So you can search for like the last thing that I included. This path is probably wrong. But if I go, is that the right path? Okay. No, that's not the name of it. Is there an underscore? No, I forget what was included or what exists in that include file. Anyway, I think this should be almost done now. So much data to scroll through. 123. It's got to be getting close now. Okay, we still have quite a few more iterations to go. Like 7 more iterations, maybe 6 at this point. I definitely did this the wrong way. Should have used a pigeonhole sort. My hope was that sorting is n log n, but the n is the number of points. So it's like the number of O points that you have at a given step. And that should be much smaller than the total number of points in the grid, because you're never going to fill the grid. A bunch of them are rocks anyway, and at each time step you can only have half of the points in the grid. And then the pigeonhole sort, the order of that would be order n, but the order n is the number of points in the entire grid. So I was hoping that n log n for small n would beat order n for big N, but I definitely made the wrong choice. I think that's like 5 steps to go. I'm not really counting, but every time it scrolls through a bunch of data, I notice it. Maybe 4 more. I should really learn how to like page up in tmux. Well, I'm not using OSX's terminal app, so this doesn't really help me. Okay, so the question was specifically terminal app. I'm really hesitant to like try random keyboard shortcuts in tmux because I'm worried that I'm gonna kill my program that's been running for like 10 minutes. So the meta key, basically, whatever you have this mapped to, and then left bracket. Ah, okay, cool. But I can't use home or end. I can only do one page at a time. And then to get out of this, I think I have to Control C, and Control C is very dangerous. Or wait, did they say something else? Q to quit scroll mode. Q? Ah, just Q. Okay, Q feels a lot safer than Control C. Because if I hit Control C to stop scrolling, I'm very worried that I will Control C and kill the program that's been running for 10 minutes. Then like, where were we? So our Y was 127. I think we have until 130. So that's 64. I think we're on the last step. Oh, I should be able to do exit here now. Ah, that's wonderful. I don't have to Control C to get out of syntran anymore. It should be the last step, and then it's just sorting. Maybe I'm off by one. It might, yeah, I guess it's going to do one more. And then it has to sort, and then it should just tell me the final number of positions. Sorting is the slow part of this loop. It's not adding up positions from relative to the old position. That's fast. The sorting is the bottleneck. And I should have done this with a pigeonhole sort with a Boolean array. And that's not even a sort, really. It just automatically takes care of the equivalence problem, where you have 2 points that end up going to 1 point. Hey, Kelly. I have to feed my cat at some point. I would have fed her like 15 minutes ago, but she was taking a nap. No jumping, please, Kelly. This takes a long time to run, but I've got a good feeling that I think I'm going to get the correct answer. Should be any second now. Callie, please don't jump. Okay. There's a number. I've got a good feeling about this, and then I might feed my cat. Okay, let's see what part 2 has in store for us. Callie, I'll feed you real soon, okay? Oh, oh. Hey, Vision for All. Thanks. Yeah, I don't know if I know how to do this. Because pigeonhole isn't really any better. That also scales up and up without any upper bound. Because pigeonhole works if your grid size is fixed, like 130 by 130. But if your grid size repeats infinitely in every direction, you first of all you have to dynamically resize your grid so that it grows as the problem size grows. And then there's like no upper limit to the complexity of your pigeonhole sort, and it's probably going to be worse than the sorting that I was doing. Yeah, part one was instantly. I did something which was kind of stupid. I decided to do something which was over complicated. Like I'm building a list. I'm building a list of the 2D coordinates of every point, and then I basically multiply that by 4 at each step, so it becomes 4 times bigger. But then I sort the list lexicographically by coordinates, and then I get rid of the duplicate values. So it took 20 minutes to run. There's got to be a better way to do this. But yeah, I could have done a faster way for part one, but it also wouldn't work for part two. And my approach, it wasn't good for part one, and it's not going to be good enough for part two either. So there has to be some more optimal way to do this. Well, I'm going to feed my cat. I'm going to think about this for a little bit, but I doubt that I'm going to figure this out on stream tonight. So I'll be back, but there might not be that much after I come back either. Come on, Joey. It's dinner time. I don't know. I might even go back to day 20 because I've been thinking about day 20 for longer. Like I just got to part 2 of day 21, and I think I need to think about it for a while before I can even start working on it. But maybe I can go back to day 20. I think first of all, I want to commit what I have right now and then maybe clean up the logging so that there's not so much junk and I have a better idea of the progress of how fast it's running so that I can try to optimize things better. Excuse me. Day 21, part 1. $26 million. That's a lot bigger than 64. Oh. I forgot to do any bounds checking for part 1. I mean, it just happened to work. But like for part 2, there is no bounds checking. You just do modulo with the grid dimension. I could at least see if I can try to replicate these values. Maybe not 5,000. I think even with the small example, my code is going to be pretty slow after like 500 or 1,000 steps or something. But we can see if I can get like the modulo logic correctly to infinitely tile the grid in every dimension. Yeah, let's at least start. Uh, Okay, so this is a little bit easier to look at. I also want the iteration or the time step. So it goes pretty fast at first, but once you start to have, it really shouldn't take that long to sort like 500 points. Why is this so slow? Like I have quick sort. I'm not doing bubble sort anymore. I have a decent sorting algorithm. Uh, is it copying? No. No, because I'm not copying the whole. Like I have this upper limit of 1,000,000 for the capacity of the points array, but I'm not copying that whole thing. I only set up to whatever the current value of NP is. I'm surprised that the sorting algorithm is so slow. Oh, you used a set. Yeah, a set is a good data structure for this problem. Unfortunately, I don't have sets. And you still can't do part two, even with sets. That's that's scary. I thought like I struggled a lot on day 17, partially because like I don't have priority queues, and like one of the great things about Python is that you import, what is it, like min heap or heap queue or something, or queue whatever, and then you just have a priority queue, and you have like the perfect data structure for the problem. Uh, but yeah, if you can't solve it in a reasonable amount of time, even with sets, I don't know what to do. Are there... Oh, I think these are just in the data to begin with. Okay, so we do have like a buffer of empty points around the outside, or we happen to for this test input. So it's like, do they have like an extra spacing between the repetitions? But they don't. The grid is just like this. So here's an idea. Basically, you have this, and then this repeats in every dimension. Eventually, and this is like a 3 by 3 repetition. It's infinite, but this, what they've given us is just 3 by 3. So eventually this one in the middle, it's going to basically fill up. And we have this like checkerboard pattern where on one step you're on all white squares, and on the next step you're on all black squares. Eventually this subgrid is basically going to fill up, and it's going to alternate between white and black, but every other step it's not really going to change. And the only thing that's changing are like the grids that you haven't filled up yet, that are like away from the center. So maybe you could use that to optimize this by once this middle one starts filling up and going into a cycle of 2, you can like stop checking it at every step. But that's still a lot of work to optimize. Like I don't know if that really helps me very much. I think what it comes down to is that syntran is just slow. Like 2000 is not a huge number, but it just takes that long to sort a vector with 2000 numbers in it. this quick sort correct? I just like copied this from somebody else on the internet, and I have no idea if this is actually quick sort. And it's iterative quick sort. I don't have recursion in syntran, so I had to find an iterative version of quick sort. Is this like the worst case scenario for quicksort? Because for quicksort, you have to choose a good pivot. And if your array is already close to sorted, it might iterate more than it needs to. So I think X is the pivot here in quicksort. And there's this thing called the median of 3. Sorry, Jimmy Wales. Yeah, there's this thing called the median of 3, where instead of just picking this as your pivot, you look at low and high and mid and pick whichever one is in the middle, and then that should be a better pivot on average for most cases. So maybe if I implement this, my quicksort might be a little faster. And it's still probably going to be pretty slow, and I'm going to have to come up with something totally different for part 2. Like this isn't going to be enough for part 2, but it might make it so that at least part 1 doesn't take 20 minutes to run. I really hate the name R. How about just V for vector? Let's do 24 steps. See how long that takes. That should not be unreasonable. It took 10 seconds. Let's go like a few extra steps. Maybe 28. And then I'm going to benchmark this and see if I can actually make it faster. There's no way I'm getting part 2 tonight, but I can at least try to optimize part 1 a little bit. So that took 19 seconds. Let me do it again to see if it always takes about 19 seconds. Okay, pretty close to 19 seconds. Now let's see if I can do this median of 3 pivot from the Wikipedia page on quicksorts. That might make it a little better. Did it? Didn't I replace? What? Oh, I'm in. Okay, I switched to a different file and I got really confused. So instead of this, I want to do the median of 3. Okay, will this be any better? It might be worse. This could be totally the wrong thing to optimize. X is O. That's a lot faster. We went from about 19 seconds to 2 seconds. That was a significant improvement. Good job, median of 3 pivot. Yeah, because like quicksort pivot, quicksort is bad when the array is almost sorted or almost the opposite of sorted. It's bad for both cases, whether it's ascending or descending, because like the at least for the code that I copied, if you copied somebody else's code, maybe they pick a better pivot somehow. But like the choice of a pivot is an important implementation detail in quicksort, because you're sorting everything compared to the pivot, and if your pivot is already one of the extremes, then you're not really sorting much of the array on one pass. You're just sorting a very small section. So when I printed H, maybe H wasn't the pivot, but H was something, and it was like decreasing by 1 every time through quicksort. I was like, quicksort should not have to iterate that many times. Something seems wrong here. Okay, now I'm curious. Can we go up to 64 in less than like 20 minutes? It's still going to slow down as we get more and more points, but it shouldn't be as bad as it was before. It's losing steam. Wow, this is so much better. I think it was about 20 minutes. We went from 20 minutes to less than half a minute. So that was like a 40 times improvement. Did not want to do a vim command right there. Yeah, I still can't do part 2. This is not enough for part 2. And if you're using quicksort from a library, it almost certainly already does this. It's not going to be like the worst possible implementation of quicksort. Okay, let's see if we can get like the modulo tiling logic correct for the example input. So instead of just stopping after 6 steps, let's see if we can go up to, I don't know, like 50 or 100 or something and get one of these numbers correct. So if I do this right now, I'm going to have like a buffer overflow or an out of bounds array index. Yep, so that overflowed pretty fast. So they very carefully picked 6 so that we could do 6 steps and not go out of bounds. But as soon as I try step 7, I'm out of bounds and I crash. So this should be easy. I'm just going to do modulo right here. X mod nx and y. This is part 1. I want to copy this and do part 2. So x mod nx and y mod ny. And it still crashes. -2. Oh, that's actually how modulo works. So I don't want modulo. I want the modulo that always gives you a positive number. That's annoying. Seems legit. Yeah. Okay. No more out of bounds array indices. And we're up to like step 100. Okay. Okay. I thought I did 500. And that's not even right. Is this... It's the same example, right? It's just tiled. That's weird. do we still get 6 steps correct? So after 6 steps, am I off by 1? That can't be it. How am I this wrong? Yeah, like I'm not even off by 1 because this is 49, not 50. Is this modulo function correct? I have an extra quote. Positive values seem okay. -1 comes out as +2, that seems right. I think those are okay. And then that should, I think that should tile the grid the way that I want it to. Oh, my 2D to 1D conversion. This breaks down. And now I think I actually need lexicographic vector sorting. Yeah, I don't feel like doing that right now. Like, well, let's just linearly extrapolate. So it took 30 seconds for me to run. After I fixed quicksort, it took me 30 seconds to run part 1. And that was 64 steps. This is 26 million. Divided by 64 times 30 seconds, let's call it half a minute. So we'll take 2 times 10 to the 5 minutes. How many hours is that? Or just divide by 60, not 3,600. So we'll take 3,000 hours. How many days is that? If it scaled linearly, this would take 140 days for me to run part 2 with brute force. So, yeah, there needs to be a way to optimize it. Like you need to check if a subgrid has filled up, and then it's just gonna flip flop between white squares and black squares, and you don't really have to bother with it anymore. So you need to optimize and like only check the shell of the expanding pattern, and like not look at the inside over and over again. It might not be that bad though, because what you can do is compare your points to the set of points from 2 steps ago. Because then you're only going to have like a very small ring of points around the outside. But then you also need binary search to see if a point from your current point set was in the point set from 2 steps ago. Yeah, I think I'm done for the night. It's late for you. All right, yeah. Have a good night. I'm not going to make much progress on this. These problems are starting to get pretty hard. Okay, I'm going to confirm that that pushed and then wrap this up. At least part one wasn't too hard today. It was really refreshing that part one of day 21 wasn't as bad as day 20 or day 19, at least for me. I don't have hash maps in my language, so I think that makes those last couple days harder. Is this the one I want to look at? This is the main commit where we got part one. So there's our code. Here's quick sort with the bad pivot. The pivot optimization was in the next commit. This just picks the last element from the array and uses that as the pivot. And it works best if the pivot is somewhere in the middle of the two extremes of the array. So if the array is already sorted or close to sorted, this is going to be close to an extreme, and this is a really bad choice of pivot. All right, yeah, that's it for tonight. I will catch you next time.